In today's video, I want to talk about chain of hindsight, which is a method that's designed to improve a language model's performance by teaching it to learn from past mistakes and using feedback. So it involves in presenting the models with a sequence of its previous output and each annotated with human feedback and training it to produce better responses over time. So let's get started. First, let's talk about human feedback dataset D sub H. So this dataset D sub H consists of tuples, which is capital D subscript H equals the set of all the tuples x, y sub I, r sub I, z sub I for I from 1 to n. So x is the initial prompt or question, and y sub I is the model's i's response to the prompt, and r sub I is the human's rating of the y sub I on the scale from 1 to 5, and z sub I is the human provided feedback for y sub I. Let's say if then a user asks a prompt X, which is explain gravity to a child, then this model generates multiple responses. First attempt y sub 1, which is gravity is what makes things fall to the ground, and the rating r sub 1, which is 3/5. And then feedback z sub 1 is good start, but can you explain why things fall? And then second attempt y sub 2 is gravity pulls objects toward each other, and then rating r sub 2 is 4/5. So the feedback z sub 2 is better, but simplify it more for a child. So it has the third attempt, which is y sub 3. Gravity is like a visible force that makes you stick to the earth. And then rating r sub 3 is 5/5. And then the feedback z sub 3 is excellent, very child-friendly explanation. So these feedback tuples are ranked by reward, which is r sub 3 is less than or equals to r sub 2, which is less than or equals to r sub 1. And then it creating the training sequence tau subscript h. This model is trained on sequences that is include the prompt, the feedback, and previous responses, which is aiming to produce the best final result, right? And the tau sub h is equals x and z sub 1, y sub 1, d sub 2, y sub 2, and so on, which is up to z sub n and y sub n. And then we fine-tuning this model. So this model is then fine-tuned to predict the best responses y sub n. In this case, which is y sub 3, which is conditioned to the entire sequence of the previous feedback and responses. And the goal is to improve the model's ability to generate high-quality responses by learning from feedback. The process is this model reads the sequence up to z sub n and then generates y sub n. So in our example, this model uses the prompt and feedback to understand how to improve its answers. It learns and that explanation should be simplified and made relatable for a child. And then another one is avoiding overfitting and shortcutting. So first, overfitting in this model might just memorize some training data rather than learning to generalize, right? The solution is to add a regularization term that maximizes this log likelihood of the per-training data, which encourages this model to retain the general language patterns. So the shortcutting is this model might pick up common phrases in feedback by using them without understanding. So the solution is to randomly mask from 0% to 5% of the past tokens during the training to prevent the reliance on some specific words. The example of masking is if we have original feedback is z sub 2 is better, but simplify it more for a child. If we mask it, the mask feedback is like better, but mask it more for a child. So this forces this model to understand the context rather than relying on some specific word like simplify. And the next one is training dataset comparison. This training data compares multiple sources to enhance learning. The first one is WebGPT comparison. So the data from models is interacting with the web queries and human comparisons. And the second is summarization from human feedbacks, which is these models summarize the text and receive human rating, right? And the third one is human preferences data set, which is some general data set of human preferences over different of responses. The next is applying chain of hindsight at test time. So at test time, this model can handle multiple rounds of feedback and then simulating a conversation. The example of interaction is user asks what causes the seasons, and then the model's first attempt is the seasons are caused by the Earth's distance from the sun, and then the user's feedback is not quite. Think about the Earth's tilt. So the model's revised attempt, which is seasons happen because Earth is tilted on its axis, which causing different parts of receiving more sound at different times of the year. And the last one, I want to talk about benefits of chain of hindsight, which improved learning from feedback by processing sequence of the feedback. This model can better understand how to adjust its responses and then also enhance the output quality. So the finally responses are more accurate and align with human expectation. And then it's generalization and regression and masking. This can prevent overfitting, which allows this model to perform well on some unseen prompt. So the chain of hindsight method trains the language model to improve its responses by learning from a sequence of its past output and associated human feedback. So just by incorporating the concrete example and the masking techniques and diverse training data, this model becomes adept at producing high quality, contextually and appropriate responses.